All right, let's dive right into this explainer. Today, we're embarking on what is literally an epic 4.5 billion year journey. We're going to discover exactly how our planet went from being this chaotic, toxic nursery floating in the dark void of space to the incredibly thriving, complex home we know today. Honestly, it's a story of extreme violence, ridiculous luck, and just sheer, undeniable resilience. I really want you to just picture the sheer improbability of our existence for a second. As far as we currently know, the universe is incredibly vast, totally empty, and completely lifeless, with one spectacular glowing blue exception. But how did that actually happen? How on earth did such an extraordinarily complex ecosystem form out of nothing more than random rocks, dust, and gravity? Well, to find out, we have to plunge directly into the violent, almost unimaginable story of its birth. So let's kick things off with Section 1, a violent, molten beginning roughly 4.54 billion years ago.
If you could somehow step foot onto Earth back then, well, you wouldn't even recognize it as our home. It wasn't really a planet as we know it. It was basically a giant, boiling ball of liquid rock. We're talking surface temperatures well over 1,200 degrees Celsius. There were absolutely no solid surfaces, just these endless rolling oceans of lava. And the air? It was this choking, heavy, toxic mix of carbon dioxide, nitrogen, and water vapor. If you were actually there, you'd be incinerated and suffocated in a matter of seconds.
But wait, it actually gets crazier. Right in the middle of this hellish landscape, a young planet about the size of Mars, traveling at 15 kilometers a second, which is like 20 times faster than a speeding bullet, by the way, slammed directly into Earth. The sheer force of the blast completely liquefied the surfaces of both planets. But from that massive cloud of rubble, gravity worked its magic over about 1,000 years, and it formed a brand new moon out of a ring of red-hot dust. And it was incredibly close, just 22,500 kilometers away, compared to the roughly 400,000 kilometers it is today. This massive impact also spun the Earth so fast that an entire day lasted a mere 6 hours. Imagine trying to get a good night's sleep with that kind of rotation.
All right, so if we fast forward through millions of years of the Earth just slowly cooling down, we hit about 3.9 billion years ago. And this marks the start of a massive, ferocious 20 million year barrage. A relentless hail of deadly meteorites, basically leftover debris from the solar system's formation, just started slamming into our young planet.
Which brings us right into Section 2, the cosmic water delivery, and how all this destruction was actually seeding life.
This is absolutely one of my favorite paradoxes to talk about. The very same deadly meteors that were absolutely battering the Earth, they were actually secretly delivering the most important ingredient for life. Think about this. The water you swallow when you take a drink, every single puddle on the street, every drop in every ocean, it is all billions of years old. It literally traveled millions of kilometers through space to reach us, locked inside these tiny crystals that kind of look like grains of salt, just hitching a ride on space debris.
So the big question is, what was actually inside all those falling rocks? Well, as the Earth finally cooled down to a relatively balmy 70 or 80 degrees Celsius, a solid crust started to form, and that allowed all this meteor water to pool into vast early oceans. But around 3.8 billion years ago, as the assault from space intensified, those meteors started bringing more than just water. They were transporting carbon and primitive proteins, amino acids, straight from outer space down to the dark, freezing bottom of the ocean. Down there, seawater seeped into the Earth's crust, got superheated, collected all sorts of gases, and spewed back out as underwater smokestacks. This created an incredibly potent chemical soup, and that is exactly where the earliest forms of life, single-celled bacteria, were born.
Jumping forward a bit on our timeline, we move from that microscopic chemical soup to a truly magical leap in evolution, right around 3.5 billion years ago.
And that takes us to Section 3, the first breath of oxygen and the absolute magic of stromatolites. Picture this. In the shallow oceans, you've got these mountains of living bacteria called stromatolites growing right out of the seabed. They looked kind of like these stunted, weird underwater trees, and they did something completely miraculous. Step 1, they absorb sunlight. Step 2, they use that solar power to transform carbon dioxide and water. And step 3, they produced glucose. That's a simple sugar, basically the same stuff we put in our coffee today. But more importantly, they produced a vital byproduct, oxygen gas. This right here is the incredible dawn of early photosynthesis. It is just wild to think that when you or I take our next breath, we are literally doing it thanks to those ancient colonies of bacteria. Over the span of 2 billion years, these stromatolites slowly, steadily filled the entire ocean with oxygen. Now, this oxygen reacted with traces of iron in the water, turning it into rust that just settled on the ocean floor. And get this, today we use those exact same iron-rich rock deposits to build our bridges, our ships, our skyscrapers. Without those ancient bacteria pumping oxygen into the atmosphere, virtually every living thing we know wouldn't exist.
But, Earth is a pretty restless place. If we fast forward again, this time to 750 million years ago, a massive supercontinent called Rodinia is starting to tear itself apart, which leads right into a catastrophic geological breakdown.
Which brings us right into Section 4, Surviving a Frozen Planet, or the era of the Big Freeze and Thaw.
The terrifying reality of what happened next actually started deep underground. Heat escaping from the Earth's molten core literally ripped the supercontinent's crust to pieces, spawning these massive volcanoes that pumped immense amounts of carbon dioxide into the air. That CO2 mixed with water to make acid rain, and the newly exposed rocks absorbed it, effectively pulling the CO2 right out of the atmosphere. Without enough CO2 up there to act like a greenhouse and trap the sun's heat, global temperatures absolutely plummeted to around -50 degrees Celsius. Earth basically became a giant frozen snowball, entombed in an impenetrable 3-kilometer-thick sheet of ice for an incomprehensible 15 million years.
But here's the thing about life, and honestly the Earth itself. It is incredibly stubborn. So how did we finally break the ice? Well, volcanoes were actually still erupting beneath all that freeze, but this time the ice smothered the rocks, preventing them from absorbing the newly released carbon dioxide. So all that CO2 just filled the atmosphere, acting like a giant warm blanket, trapping the sun's heat and finally melting the ice. And check out this fascinating chemical twist. While the planet was frozen, UV light reacting with the ice had created hydrogen peroxide. As the ice finally melted, that hydrogen peroxide broke down and it released a massive explosive surge of oxygen into the newly warmed oceans.
Following our timeline here, you can see how that massive, explosive oxygen boost completely paved the way for complex, multi-celled organisms to finally thrive. By about 540 million years ago, the oceans were just bursting with advanced life, setting the perfect stage to conquer the land.
And that launches us into Section 5, the rise of complex life, and the incredible result of this changing environment.
So why did life finally decide to pack up and move onto land? Well, it turns out all that new oxygen met up with solar radiation high up in the atmosphere, and it created a brand new gas, ozone. This thickening ozone layer acted like a planetary shield, absorbing the sun's lethal radiation. Before this happened, stepping on land pretty much meant instant death. Now, it was a protected haven. Down in the oceans, evolution was taking these massive leaps. We went from 60-centimeter-long monsters with razor-sharp teeth called Anomalocaris to the very first primitive spines. Soon, creatures like Tiktaalik actually started using their fins as legs to drag themselves out of the water. Thanks to the immense oxygen levels up on land, we started seeing giant mosses, seeds that could actually survive away from the water, and enormous bugs. I'm talking things like Meganeura, a dragonfly literally the size of an eagle, and millipedes that were 2 meters long.
Of course, progress on Earth is rarely a straight line, right? About 250 million years ago, the entire landscape of the Siberian plains just erupted. Millions of tons of molten rock poured out, causing highly toxic acid rain, heating the oceans, and releasing these frozen pockets of deadly methane gas right from the seabed. Global temperatures spiked to 40 degrees Celsius. This was the Permian extinction. It completely reset the evolutionary clock by wiping out 95% of all life on the planet. That tiny 5% that actually survived, they only managed it by burrowing deep underground and eating absolutely anything they could find.
Now, from the ashes of that nightmare, the dinosaurs evolved. And they dominated. They thrived for 165 million years, surviving shifting continents and tearing oceans. But then, 65 million years ago, a 10-kilometer-wide asteroid, literally bigger than Mount Everest, slammed into the Gulf of Mexico. The impact instantly vaporized the rock, sending a 275-degree blast wave around the entire planet, burning up vegetation and completely blocking out the sun. The supposedly invincible dinosaurs were completely wiped out. Yet our remarkably resilient omnivores, mammalian ancestors, who are already pretty used to hiding underground to avoid the dinosaurs anyway, managed to survive the apocalypse. And just like that, they inherited the Earth.
Ultimately, though, this entire absolutely wild narrative ties directly to us. The whole path to humanity is basically built on a series of catastrophic geological coincidences. The Indian plate slammed into Asia, buckling to form the Himalayas, which permanently changed global water systems. An East African rift caused huge mountains to grow, which blocked moisture and turned lush green rainforests into incredibly dry savannas. This literal climate shift destroyed habitats and actually forced our ape ancestors out of the trees to search for food, compelling them to stand up and walk on 2 feet. Even the later ice ages worked in our favor. They lowered the sea levels just enough to reveal land bridges, allowing early humans to migrate all the way from Asia into the Americas. Basically, every shifting tectonic plate and retreating glacier directly shaped our existence.
Which brings us to a pretty mind-bending final thought to wrap up this explainer. We've just spent all this time looking back at a 4.5 billion-year journey full of fire, ice, mass extinctions, and just miraculous evolution. But get this, Earth is expected to live for at least another 4.5 billion years. We are literally only at the halfway point. Just imagine, based on all the extreme violence and incredible resilience we've explored today, what unimaginable wonders, terrifying events, and entirely new, strange creatures might lie ahead in the unfinished story of our restless planet. I really hope this leaves you as totally fascinated as I am. Keep learning, keep questioning, and I'll catch you in the next one.